Now, how would you answer this question? What is the probability of getting the first 6 on the 4th row using a 6-sided die? You need to realize that this is a geometric distribution. You're trying to find a probability that a successful event will occur on the 4th try. So during the 1st row, you're going to get a failed event. During the 2nd row, it's another fail. But during the 4th try, you're going to get a successful event. Now, we're dealing with a 6-sided die. And so if we write out the sample space, these are the numbers that we can get if we roll a 6-sided die. So what is the probability of not getting the 6? The probability of not getting the 6 is there's 5 numbers that are not 6 out of the 6 possible numbers. So it's 5 out of 6. So that is the probability of not getting a 6 on the 1st try. The probability of not getting a 6 on the 2nd try is 5 out of 6 again. And for the 3rd try, it's the same. Now on the 4th try, we want to get a successful event. We want to get a 6. The probability of getting a 6 is 1 out of 6. So we have 3 fail events, which is 5 over 6 to the 3rd power, times the probability of 1 successful event. So that's 5 to the 3rd divided by 6 to the 4th. 5 times 5 times 5, that's 125. 6 to the 4th is 1296. So if we divide those two numbers, that's going to give us 0.09645. Multiplying that by 100, this is approximately a 9.6% chance that we can get the first 6 on the 4th row using a 6-sided die. Now, for those of you who like to use a formula to get the answer, here it is. So the probability of getting, well, let's just say the probability of a geometric distribution, it's going to be, big X is the random variable, little x is like the trial that you want to get the successful event. This is going to be equal to Q raised to the x minus 1 times P. Now, lowercase p is the probability of getting a successful event. Q is the probability that an event will fail. Now keep in mind, Q is 1 minus P. So in some textbooks, you'll see it written like this. So just keep that in mind. So to apply this formula in this problem, we have capital X, the random variable, little x, that's going to be 4, because we want to get a successful event on the 4th row. Q is the probability of not getting a 6, which we said is 5 over 6. X is 4, so this is going to be 4 minus 1, times the probability of getting a successful event, in this case, successfully rolling a 6, that's 1 out of 6. And so as you can see, this will give us the same answer, which is going to be 0.09645. But that's how you could use the formula in order to calculate the probability of a geometric distribution. Number 2, 15% of all cars passing along a certain road are blue. What is the probability that the 7th car will be the first blue car that you see passing along this road? So let's write the formula first. So the probability of successfully seeing a blue car is 15%, or 0.15 as a decimal. So the probability of not seeing a blue car, it's going to be 1 minus 0.15, or 0.85, which is 85%. Now what is little x in this problem? This is going to be 7. So we want to get a successful event on the 7th try. So it's going to be the probability that, or if x equals 7, Q is 0.85 raised to the 7 minus 1, which is 6, times P, which is 0.15. So just think about what this means. On the first 6 tries, or the 6 cars that you see, you're not going to see a blue car. And the probability of not seeing a blue car is 0.85. The 7th car that we want to see is a blue car, and there's a 15% chance of getting that. So that's why we have 0.15. So these two numbers must always add to whatever number you see here. Now let's go ahead and get the answer. So it's 0.85 raised to the 6th power times 0.15. And this is equal to 0.05657. So there's approximately a 5.7% chance of seeing a blue car I lost my train of thought. Of seeing a blue car as the 7th vehicle. There we go. Number 3. 4% of the population in a small town work as a teacher. What is the probability that the 10th person that you encounter in this town is a teacher? So let's identify the variables x, p, and q. 4% of the population are teachers. So P is 0.04. That means that 96% of the population are not teachers. So that's 0.96 for Q. Little x is going to be 10 since we want to get a successful event on a 10th trial. Now let's write the formula. So let's replace little x with 10. Q is 0.96. 10 minus 1 is 9. And P is 0.04. So it's 0.96 raised to the 9th power times 0.04. So this is equal to 0.0277. So there's approximately a 2.77% chance that the 10th person that you encounter in this town is going to be a teacher. Now let's move on to part B. Let's calculate the mean, variance, and the standard deviation. So let's start with the mean. The mean is 1 over P. So it's going to be 1 over 0.04, and that is 25. Now what about the variance? There's a simple formula that we could use to calculate it. It's sigma squared, which is 1 over P times 1 over P minus 1. Now keep in mind 1 over P is the mean, as we could see here. So 1 over P is 25. And then times 1 over P minus 1, that's 25 minus 1. So this becomes 25 times 24. Which is 600. So that's the variance in this problem. Now the last thing that we need to calculate is the standard deviation. The standard deviation is the square root of the variance. So in this case, it's the square root of 600. And that's going to be 24.49. So that's it for this problem. That's how you can calculate the mean, variance, and the standard deviation. Number 4. 2% of all tires produced by company XYZ has a defect. A random sample of 100 tires is tested for quality assurance. What is the probability that the 8th tire selected has a defect? So go ahead and take a minute and try this problem. So let's write down what we know. So what are the values of P, Q, and X in this problem? Well, 2% of all tires has a defect. So P is 0.02. That's the probability of selecting a defective tire. The probability of not selecting a defective tire is going to be 1 minus 0.02, which is 0.98. Now, in part A, we want to calculate the probability that the 8th tire selected has a defect. So X is 8 for part A. So let's write the formula. So we need to find the probability that X is equal to 8, Q is 0.98 raised to the X minus 1, or 8 minus 1, which is 7, and P is 0.02. So it's 0.98 raised to the 7th power times 0.02, and you should get 0.01736. So there is a 1.7% chance of selecting a bad tire during the 8th trial, or during the 8th sample. Now, let's move on to part B. What is the probability that the first defect is identified among the first 5 samples? So how do we get that answer? So we need to calculate the probability where X is less than or equal to 5. So this is going to equal the probability where X is 1 plus when X is 2, all the way to when X is equal to 5. So we need to add up the individual probabilities to get this answer. The probability when X is equal to 1 is going to be Q raised to the X minus 1, which is 1 minus 1, so that's 0, times P to the first power. For the second one, it's going to be Q raised to the X minus 1, or 2 minus 1, which is 1, times P to the first power. And then if we repeat the pattern, this is what it's going to be. So for the last one, it's going to be Q to the 4th power, P to the first. Notice that the exponents always add up to X. When X is 3, you have 2 plus 1. When X is 5, 4 plus 1. So we already know what Q is. Q is equal to 0.98. And P is 0.02. Now, to make this easier, what I'm going to do is I'm going to factor out P, since it doesn't change. Q to the first power is basically 1. So I'm going to have 1 plus Q squared plus Q to the 3rd plus Q to the 4th. So it's 0.02 times 1 plus 0.98, and then plus 0.98 squared, and then plus 0.98 to the 3rd power, and then plus 0.98 to the 4th power. Go ahead and plug this in your calculator. I got 0.096079, which is approximately 9.6%. So that's the probability that the first defect will be identified among the first 5 samples. Now, for those of you who might be confused on how I got this part of the formula, here's how you can get it. So let's say if you're determining P of X equals 1. Remember, P of X equals X is Q to the X minus 1 times P. So when X is 1, this is Q 1 minus 1 times P, which is always going to be P to the first power. So you get Q to the 0, P to the first. Let's say when X is 4. This is going to be Q raised to the 4 minus 1 times P to the first power. So you get Q to the 3rd, P to the first. And when X is 5, this is going to be Q 5 minus 1 times P to the first power. So it's Q to the 4th, P to the first. Just in case you were kind of confused in terms of how I got these values. So it all comes from this formula. Now, is there an easier way of getting the answer? Because what if we had to find the probability that the first defect will be identified among the first 20 samples. That will take a longer time. It turns out that there's a simpler formula to get the same answer. And here it is. This is known as the cumulative geometric distribution function. And it's p of x, where it's less than or equal to little x. That's going to be 1 minus q raised to the x. So this is the formula that you want to use for a problem like this. So in this case, little x is 5. So this is going to be 1 minus 0.98 raised to the 5th power. So go ahead and type that in. This will give you the same answer of 0.09607. So make sure to add that formula to your list of other formulas that you need to know. So now that we have this formula, we can use it to calculate the answer in part C. What is the probability that the first defect is detected among the first 10 samples? So this is going to be P of x is less than or equal to 10. Using this formula again, it's going to be 1 minus 0.98 raised to the 10th power. And so the answer is going to be 0.182927. So that's approximately an 8.3% chance that the first defect will be detected among the first 10 samples. Now, what about part D? How many tires would you expect to test until you find the first defective one? How can we find the answer to that question? So go ahead and think about it for a minute. Pause the video if you will. The answer is the mean. All we need to do is calculate the mean, and that's going to determine the number of tires we expect to test until we find at least one defective one. So the mean is 1 over p. And the probability of finding a defective tire is 2% or 0.02. So 1 divided by 0.02 is 50. So you should expect to test 50 tires until you find one defective one, because that's the mean. So that's it for this problem. Number 5. 2% of all tires produced by company XYZ has a defect. A random sample of 100 tires is tested for quality assurance. Calculate the following. So go ahead and try these problems. It's based on a previous problem. So what is the probability that X is less than 7? What is the probability that we're going to find a defective tire within the first 6 samples? So keep in mind P of X, which is less than 7, this includes all the numbers from 1 to 6. It does not include 7. So how do we get this answer? Now remember the formula that we used before. P of X less than little x is 1 minus q to the x. So right now we have the less than symbol, but not the less than or equal to symbol. However, we can turn this expression into something like this, because this is 1 to 6. So we could say that P of x less than 7 is equivalent to P of x, which is less than or equal to 6. So now we can use this formula. So this is going to be 1 minus, now keep in mind q is still 0.98 and p is 0.02. So this is 1 minus 0.98 raised to the 6th power. And that is going to be 0.11416. So there is approximately an 11.4% chance that a defective tire will be identified within the first 6 samples. Now let's move on to part B. So what is the probability that a defective tire will be found, let's say, beyond x is greater than 12. What formula can we use to calculate this particular probability? Let's draw a picture. So this is the shape of a geometric distribution. We have the probability on the y-axis, the random variable x on the x-axis. Now this is going to range from 0 to infinity. But for this problem, our focus is 12. This region here, let's separate it into two parts. The region on the left represents the probability where x is less than or equal to 12. The region on the right represents the probability that x is greater than 12, but not equal to it, since we included 12 on the left side. Now, the area under this curve from 0 to infinity has to equal 1, because that's the most that probability can be equal to. So if we add these two values, this is equal to 1. Now what I'm going to do is I'm going to rearrange this equation to get this one. But first, let's write it in terms of little x. So taking this term and moving it to that side, we have the probability that x is greater than x is equal to 1 minus the probability that x is less than or equal to little x. Now, we have the formula for this expression, which is what we have here. So this is going to be 1 minus q to the x. Now let's distribute the negative sign. The ones will cancel, giving us q to the x. So the probability that x is greater than little x is simply q raised to the x. So now we could use that to get the answer for part B. So this is going to be 0.98 raised to the 12th power. Which is 0.78472. So there's a 78.5% chance, approximately, that a defect will be found beyond the 12th sample. So the defect will be found between sample 13 to sample infinity. Now let's move on to part C. So what is the probability that the defect will be found from sample 18 to sample infinity, or x is greater than or equal to 18? So we're going to use this formula again, but we need to change it into this form. So this is between 18 to infinity. So we could say that we're looking for the probability that x is greater than 17, because this does not include 17, but it includes everything beyond 17, which is, once again, 18 to infinity. So now we could use this formula. This is going to be 0.98 raised to the 17th power. And so that's going to be 0.70932. Or we could say that there's a 70.9% chance of finding a defect beyond the 17th sample. Now, let's move on to part D. What is the probability of finding a defect between sample 15 and sample 30? To get this answer, we need to draw a picture once more. So let's say 15 is here and 30 is in this region. This is going to be 0, and that's infinity. So let's break this graph into 3 parts. We'll call this region A, B, and C. So the area under the curve for region A would be the probability where x is less than or equal to 14. For region B, that's what we're looking for. That's going to be from 15 to 30. And then region C, it's going to be beyond 30, so we're going to start with 31. Now, these values must add up to 1, because the probability from 0 to infinity has to be equal to 1. Our goal is to calculate this value here. So let's rearrange the equation to solve for this expression, which means these two expressions we need to move to the other side. So I'm going to erase this picture at this point. So we could say that the probability of finding a defective tire from sample 15 to sample 30 is going to be 1 minus p of x is less than 14 minus p x is greater than 31. Now let's get rid of this, and let's focus on calculating these two values first. So what is the probability that x is less than or equal to 14? So what's the formula that we could use for this one? So it's p of x is less than or equal to little x, and that's equal to 1 minus q to the x. So this is going to be 1 minus q, which is 0.98, raised to the 14th power. And so that's going to be 0.24636. Now, let's calculate the probability that x is greater than or equal to 31. So this is the same as x is greater than 30, because that would still be 31 to infinity. So we're going to use this formula. It's simply q to the x. So that's going to be 0.98 to the 30th power. Which is 0.54548. So now the final answer for this problem is 0.20816. So we could say that there's a 20.8% chance of finding a defective tire between sample 15 and sample 30. Now let's move on to the last part, part E. So let's calculate the probability that a defective tire will be between sample 20 and sample 45, but not including sample 20. So this goes from sample 21 to sample 45. So this is going to be 1 minus the probability that x is less than or equal to sample 20. So that's from 1 to 20. And then minus the probability that x is greater than 45. So this includes sample 46 to infinity. So make sure you don't include a sample twice so that you don't get the wrong answer. Let's calculate this value first. So this is going to be 1 minus 0.98 to the 20th power. And that's 0.33239. Now, using the second formula, we can calculate the probability that x is greater than 45, which is 0.98 raised to the 45. And so that's going to be 0.40288. So the final answer is going to be 0.26473. So there's approximately a 26.5% chance that we're going to find a defective tire between sample 20 and sample 45, but not including sample 20. Now let's take a minute to review the formulas that we've covered in this video. So here's the first one. The probability that x is equal to little x. This is where we get a successful event after a certain number of failed events. And this is going to be q raised to the x minus 1 times p, where p is the probability of a successful event and q is the probability of getting a failed event. Now we also said that the probability that x is greater than little x is q to the x, and the probability that x is less than or equal to little x, that's 1 minus q to the x. Now what about the probability that x is equal to or greater than x? In this case, all you need to do is subtract x by 1. So notice the similarities between these two formulas. Because by adding the underline, you're introducing an additional value. Now for this one, which is similar to this one, where x is less than little x, it's going to be 1 minus q raised to the x minus 1. Now the remaining three formulas that we've covered are the mean, which is 1 over p, the variance, which is 1 over p times 1 over p minus 1, and the standard deviation, which is the square root of the variance. But you can also use this formula to get it as well. It's the square root of 1 minus p over p squared.